and I'm greatly appreciate the fact that you're all still here, as yes, and the final group appreciates it too. So I want to move on to our what I think is it brings together a number of the themes that we've been talking about over the last, well, this morning and yesterday. And so I'm joined here by Kevin Hall and Heather Kennedy to discuss the broader question of what our engineering capacity is for, or what is the engineering capacity that we have, that we need to attain to be successful in this energy transition. So I'm going to start off with a few comments and sort of stimulus questions, and then I'll pass to Kevin and then to Heather, and we'll hopefully turn it into a full discussion on the floor. So, you're not going to be able to see this, right? Because anyway, next time we'll put a screen up there. So I'll read through this, right? But you know, one of the big things about the energy transition challenge is its breadth and the interrelation between the various areas. So electricity generation and transportation, oil and gas production, transportation in general, heating and cooling of buildings, industrial consumption, including mining, agriculture, carbon capture, usage and storage, waste, right? All of these are linked in our sort of national systems and ecosystems, and they are all going to change, and some of them are going to morph from one to another, and some of them are going to displace other ones. And so engineers, most of us have had fairly multi-dimensional careers as various aspects of industry grow and fall, and you know, anybody in the private, if you're an engineer in the private sector in Canada, you're a brave soul. You don't really know what you're going to be doing in 5 years' time. So I think the next generation is going to be fully aware of this coming into it, I hope. There's also some major financial implications that touch on the engineering profession, right? So we have this $2 trillion number, which following the previous panel's discussion of how rare it is for a project to be delivered on time and on budget, we'll just round the 2 trillion off to 3 trillion as to what it'll probably cost. And then the question is, how much of that money will stay in Canada? So, you know, and a lot of that question is tied to industrial capacity and engineering capacity. How much of that is going to have to be outsourced to non-Canadian based organizations, simply because Canadian organizations don't have the capacity, or because the capacity will be tapped out? And I loved it when Yves was giving his presentation on the refurbishment of the Royal Victoria at McGill, and how the fluctuation in price of his $800 million project is completely shifted by whether or not the interest rates go up a bit, and the Quebec government has released a couple of projects. That's one $800 million project, and we're talking about dropping tens of billions simultaneously, and expecting it not to negatively impact the engineering market. You know, so what are the potential cost and schedule overruns? And Colin talked about the How Big Things Get Built book, which I, you know, as a late night read is a blast. But you know, most solar and wind energy projects get delivered within 10% of their original cost. Most nuclear power plants don't. On the other hand, the Canadian experience was Pickering and Darlington, Bruce and Pickering did, and Darlington really didn't. So, you know, it's a little hard to understand what are the key factors. And, you know, one of the issues that gets discussed is there's supposed to be all this innovation that has that's going to result in technologies that can solve the climate change mitigation problem. They actually have to be cash positive. I mean, they actually have to be solutions that not only technically work, but work from a business perspective in a competitive environment, or else the companies are just going to go out of business trying to implement them. So, so there's that issue about how we develop technologies that are not only technically feasible, but economically feasible. And it's the nature of climate change mitigation that the longer we wait, the worse the problem gets, the more it costs. So, and then there's the skills implication, right? So Canada, it's hard to actually, I was having trouble finding the engineering data. It all seemed to be very dated, so like 2014 type data. So I think there's a new study coming out. But you know, we need to retrain and train a large number of people. We have a huge EDI problem in terms of what the representations are across the various groups. And you know, not just in Eve's example, but I know when I was first graduating in 1980, there was this big boom out west, and it stole all the engineers from the east, and then the boom stopped, and then everybody came rushing back again, right? So, and it doesn't seem to have changed very much. So one of the reasons we put this panel together was the Academy is actually working for Engineers Canada on a paper called, a research paper on energy engineering. And the question really is, what is an energy engineer? Because weirdly, they don't exist in theory anywhere. It's not a recognized discipline. Now, it's just starting to be, and University of Calgary, Ontario Tech have started programs in energy engineering, but it's a very, very recent occurrence given that we've been engineering energy for 150 years. So one of the questions then is, so let's say we have energy engineers one way or another, what is the gap between the number that are in the pipeline and the number that we will need? Do we know the number that we will need? It has the energy transition has huge implications for Indigenous communities, which we've talked about it a number of times. What does this mean for engineering education? And one of the other questions is, you know, youth will do what youth will do. And there's a large sentiment in the current youth population. They want to do something about climate change. It's not entirely clear they want to do something as difficult as get an engineering degree. So, so those are just some questions that I thought I would throw on the table and let you guys at it.
All right. Well, thanks. I'm up first, and I'm going to do what a typical academic is and veer right off the question to something else and then sort of come back in. And I did, for a reason, I just want to really start talking about what I perceive as a lack of commitment to a knowledge-based economy in this country. And it's something that I've been banging on about for 40 years. I know I don't look that old, but you know, we as a country, it's too easy to dig things out of the ground and ship them overseas or cut down trees. And we've never really thought about knowledge. And you know, just the OECD statistics are, we're at the bottom of the tier 1 countries, of 20 countries. We were 4.5% knowledge-based economy in 1980. We're now at 6% knowledge-based economy in 2020. If you look at Sweden, they were right with us at 5% in 1980. They're now 50%. And so they add value to everything they do. And they cut a lot of trees down, but you know, they do smart things. Like IKEA now is making modular homes for people with specific disease. You can buy an Alzheimer's home. You can buy a stroke recovery home. You can buy et cetera, et cetera. And I think for Canada, and particularly as we look at this energy space, you know, are we going to give this away again like we've given everything else away? And so I think we really have to look at a knowledge-based economy. And I'll give you my own personal example. You may have noticed I'm limping around here. I had a knee replacement that went really poorly because the surgeon made a big mistake. But the thing about this story is my knee is a beautiful new design out of Vancouver. by Stryker, and it's called the triathlon knee, which is appropriate because that's how I screwed my knee up in the first place. But it's made out of titanium that's mined in Kirkland Lake. It's shipped to the U.S. where the titanium is processed. It's powdered, and then it's printed in the U.S. on a 3D printing using additive manufacturing and sent back here. And it's just like, you know, what have we done as a country? We've missed this opportunity, and I'm afraid we're going to do that in energy. And so I think something we can all do is lobby as this group around a knowledge-based economy. And in fact, you asked last night for new fellows, what are we going to do for the society? I'm going to stick my hand up and say, I'd love to start a panel on knowledge-based economy. So anybody that wants to join in, feel free. Now, I'll get back to the question. So for us at universities, I think there's, you know, three basic places where we could play. The first is in, you know, high-level training that's really needed for the planning and execution of multi-billion-dollar projects or multi-billion-dollar industries, which are the potential. And so what is the university's role in that? And that is about engineering, but it's about other disciplines as well. We have to recognize that we don't solve all of the problems. We need to get new engineers interested in climate, sustainability, and energy, and everybody's interested in climate. They all stick their hands up. A few are interested in sustainability, and then when you talk about energy, it's kind of like it's a glaze, like what's energy? Because people think of energy as the traditional sectors of energy in this country, and we probably need to keep those traditional sectors, but again, we need to use knowledge to make them more effective, to make them more environmentally friendly, et cetera, et cetera. And then there's kind of the research and development place. And I think we're just starting the journey in academia in Canada in all three of those. And if you look globally, there's quite a bit of activity going on, and I'll start with one that's near and dear to me. I just came from Australia to Victoria 2.5 years ago, and I was fortunate enough to be the vice president of research at a university that had the largest energy cluster in the country, called the Newcastle Institute for Energy and Resources. It was 350 academics, 1,000 Ph.D. students, and undergrad programs that were delivered by the Institute. And it's now the home to the Australian Hydrogen Hub, the New South Wales Energy Transition Centre, et cetera, et cetera. And I think we've got to start thinking about some of those things at our institution. How do we work together? For example, in BC, you know, UVic, UBC, SFU, the sort of research powerhouses, we really don't do much together. And why is that? As opposed to the Australians that work together, because the government actually bangs their heads and work together. And one of the concepts that they're using is called the Doctoral Training Center, which I think would be fantastic for the energy sector, where companies, industries, governments that are in competition with each other but have common problems to solve, throw money into a pot, and the students work as a PhD team in a cohort with an industry co-supervisor, with an academic supervisor, and end up producing PhD graduates that don't want to become academics. They actually want to go work for the industry that they've been trained in, and it works really well. Newcastle had one in energy transitions. They had one in beneficiation, which is an interesting concept, right? So what do we do with these phones, for example, that have 57 rare earths in them? We just throw them away, right? And we're talking about critical minerals and how we've got to keep mining them. Well, there's actually, they're mining minerals out of these phones, and everybody says, well, you can't do it, it's too small, it takes too much energy, but they're working on that problem. I think the other piece is undergraduates. How do we engage them? How do we create in the energy industry placements for those students to have either a short work integrated learning experience or a co-op experience? And I'll just point to Germany, where the Fraunhofer, anybody familiar with Fraunhofer institutes? They're basically, industry, academic partnerships. They specifically now are having, at their energy Fraunhofers, of which there's 6 in Germany, they have, not just PhD programs now, they have undergrad student placement. Go work at the Fraunhofer, work with industry partners. So we could start looking at that. Uppsala in Sweden has an energy course, an energy program in engineering. They just call it sustainable engineering, but the focus is on energy, because apparently energy doesn't attract people, but sustainability does. And I think the other piece for me is the transitions piece, and as we look at transitioning energy sources onto our existing grids, it's a challenge. The technical piece, I think, is the easy challenge, the engineering piece, but it's more the social, it's more the economic pieces. And so how do we work as engineers, as educators of engineering, to expand our programs beyond just engineering. So how do we get out of this box that we get put in with CEAB, for example, and actually have students that can participate in a much wider branch of programs? And a good example, if you want to look at this one, is if you go to the University of Freiburg in Germany, they partner with Strasbourg in France and Bern in Switzerland. They're all located within less than an hour of each other by train, where students go to all three universities and pick up courses in engineering, in social science, in economics, in startups, and all kinds of things. And so I think we could do things like that. The biggest concern, I think, is, you know, when I went to school, if you wanted to go into electrical, you had a choice. You became a power engineer, or you became, at that time, the burgeoning electronics engineer. I think the circuit boards were about this big. You know, we've lost in this country the capacity to work on power systems and energy systems. And so I don't think we're capable of mounting energy programs yet at most universities, because we've been focusing on microelectronics and computer science and computers and software and things like that. And so I think we have to start rebuilding that at institutions. And to do that, we have to get governments on board, because governments pay for seats at universities. And so, I mean, as over here, our dean, she's just been given 650 seats from the BC government, which is fantastic, and we're very appreciative. But they're in computer science and software engineering. They're not in energy. So, you know, we, I guess, as a group, and the industry has to start lobbying the government to start providing funds to create programs in energy engineering. The other piece, I think, is, you know, to get this diversity that we're talking about in engineering, we had a good panel yesterday on EDI and how tough it is. We want to reflect this country in the engineering profession. We need to start thinking about what's our role as universities and as industry in the K-12 system, and as early as, you know, grade 3, 4, and 5, we should be talking about energy and why that's important and how that contributes to climate, because there's that disassociation of climate. And what else did I just want to say? Just a couple other things. I think if we do go down the route of a energy degree, whatever it will be called, an energy engineering degree, then we've got an uphill battle to fight as well with the accreditation board to make sure things are okay. We've got our P.Eng associations that are, you know, certifying or giving people a license. There's a lot of work we have to do within those groups to make sure that we can start to push this forward. And again, I think industry in particular, we need to have them come along and start playing with that, you know, start pushing those concepts. And so I'll be quiet now.
Oh, that's great.
Yeah.
Thank you so much. Heather.
Yeah, thank you. By way of background, my personal background is in the resource sector. I worked for several decades in mining, oil sands, in operations, major projects, and regulatory. So I quite enjoyed the previous presentation, and we'll cite it actually here in terms of the chaos around oil sands and what it might look like for an energy transition.
So can I refer to you as the no-knowledge economy?
Only once. Only once. So the spoiler alert is, the answer to the question is, do we have enough engineers? Will we have enough engineers? The answer is no. And I'll talk a little bit about the size of the transition, some of the issues that I see, and some things that we do know and some things that we don't know. And I should point out, I'm actually here on behalf of Sohail, who couldn't stay, so I do have my CAE hat on at the moment, so these are not my personal views. No, just kidding. I think, you know, there's a couple things that are important. So some of this we've heard already. So, you know, 85% of Canadians believe that climate change is real, and 73% think that we should change our ways to avoid environmental disaster, and 30% have any idea what to do about it. So that means 70% of Canadians would like the problem fixed, but we don't have any idea what to do about it. And so there's a clear gap for engineers and others who have the knowledge base and the science to go with it. When we talk about the size of the transition, you know, Robert talked about this a little bit already, somewhere between $2 and $10 trillion over the next 30 years. I don't even know how many zeros that is really, but it's huge. And when you think about that, I'm sure all of us are kind of going to, oh, big new infrastructure, Site Cs, new nuclear plants, well, maybe tidal. Still don't understand why we don't have any tidal in Canada, but big infrastructure. But let's layer on that a couple of other very important factors. The second piece is rebuilding aging infrastructure. The electrical grid, as we heard earlier, I live a lot in central BC, and well, first of all, I don't need to worry about 6G. I'd like to get to 3 actually, but we routinely have power outages because the lines fall down. So climate adaptation is incredibly real. So I think the aging infrastructure is another critical point. The other critical point is artificial intelligence, other technological developments. They're coming at engineers and scientists and people who have to address these problems faster than you can absorb them. So you might today think that's how you're going to build a nuclear plant. That's not how you're going to build it tomorrow. But as I'll talk about later, those are multi-year projects. So you're going to find yourself in the middle of a project with some technology that didn't exist when you started. How do you incorporate it? So that adds to the complexity. We also have, I think, a strong mandate around being more efficient and effective. So, with no disrespect to Eve from this morning, one of the things that crossed my mind was, why does McGill need a brand new, lovely center at all? Thank God he's gone. But, yeah, and please no one tell him I started this conversation. But that's just one example for me of maybe there's some tougher decisions to be made and about what we build and whether we actually need some things. And I'll talk a little bit more in a minute. Then there's also societal expectations. Tolerance for failure is hugely low in this country. Things that make this unique in my mind. So all the previous major energy transitions in the world, from fires and hunters and gatherers all the way to today, have always included increasing ability to consume more energy. This one wants us to both increase and consume less. So we're going to completely transition energy, and we want to do less. We've never done that before as a human race. Capacity, in this case, when we talk about capacity, it's 3 things in my mind. One is the actual numbers. You actually need bums in seats, to use an expression that we would have used at Suncor when we were trying to find people. Bums in seats. But engineering capacity is changing, and I think, Kevin, you talked about it a lot. It's no longer good enough to just be good at one thing. If you want to build a plant somewhere, in my experience, you better be way good at a number of things, and patience as well. And you have to, lastly, really understand a changing mandate around public safety. Our energy costs are amongst the lowest in the developed world. And, I'm a bit of a political junkie, and I read the news every day, and, there's a slight increase in costs, and the entire nation, we're up in arms, we want a new government, et cetera, et cetera. There's a reality check in there that is going to add to the challenge. You cannot build all this infrastructure, you cannot change your energy grid, you cannot change the entire, meet all the societal expectations and still have low energy cost. There's a collateral around hydrocarbons. There's a whole suite of Canadians who would like to see hydrocarbons stay exactly where they are forever. And from an energy perspective, that's likely doable. I'd say heavy on the likely part. But there are too many products, too much quality of life, too many important things to us that are tied up in hydrocarbons. And engineers are going to have to help address that problem. I think actually, I think Guy said it earlier today, maybe it was Guy, maybe it was someone else, but there are so many pathways to net zero. Everybody has a good idea. Every sector's, we're going to solve the problem. So that's going to be a huge drain on engineering time to model all those scenarios, to think about all those options, to make all those choices. Another drag on the resources. Canadians, there's 302,000 licensed engineers in Canada today. When engineers graduate from engineering school, I'm probably the only person in here with only a bachelor's degree, but anyway, only 66% of them actually go right working in the field. Now, about 13% will go on to do advanced degrees, and Thank goodness for all of you who chose that. So that's not a complete drain on the profession, but it's still, well, in terms of, work. But, so that means a whole bunch of folks go into engineering school and come out and don't work as engineers. Of the 66% that go to work, only 70% stay in the profession for a material length of time. So do the math. So for every student that goes into engineering school and graduates, less than half of them will actually have a career in engineering and be able to provide value in that. So here's a list of things that I think we don't know to deal with this transition and the energy capacity. We don't even understand what the challenge is. How many engineers and in what field and with what experience are required to meet the challenge? That question today cannot be answered. And how much of the work that engineers do today is actually engineering, and how much can and should be done by others? So when I think about my career and the work that I did, how much of that could have actually been done by someone else, but we've decided that, iron rings and engineering degrees and stamps are required for that. We may have to make some different decisions about that. And who do engineers need to partner with to give success its best chance? And then lastly, the thing that we don't know, to even have a solar or wind plant approved in this country, so this is from really good idea to, okay, we're gonna build it, never mind construction, 10 years. Now, I know you talked about not wanting to mine anymore, and given my background, we can chat later, but a mine, even, say critical mineral mine, 17 years on average. So the things that we don't know is, are we able as a country to understand all of our important stakeholders, all of our federation, uniqueness that makes us special, and yet do it well and quickly? And we have to change that, or, we're not gonna need to worry. Here's the things that I think we do know. So we do know some things. We want success. There's no doubt in my mind that most people in Canada, politicians, engineers, et cetera, want success. Another thing we do know is that Canadians' understanding of energy literacy is the lowest in the Western world. So we're not having the right conversations. I've heard a lot about Germany lately, and I'm thinking, around the kitchen table in Germany, they're having different conversations than we are at our kitchen tables, right? I don't know that. I do know lots of German engineers, and I imagine they're having some pretty interesting conversations. So when you add up, so the research has shown that this lack of energy literacy, our regulatory framework, and our policy development inertia actually might stop us before we even get to construction. And if you think this isn't an engineering problem, think again. It is an engineering problem, because only engineers can help answer any number of those questions. So imagine the draw on engineers just to get the answers to those questions. We haven't even started to design and build things. Project owners always want bricks and mortar. We have to get through that. We have to decide maybe we don't need to build this. They always want something fancy and beautiful, right? When was the last time you saw anything utilitarian built in this country, except when you have to get to value engineering and you'll add it later? But those are real problems, right? We have to change that culture, and engineers can do that. How do you have something look good, be practical, and not be fancy? Because we don't have time and we don't have money for fancy. Never underestimate the difficulty of multiple parallel projects in one time. I can talk to you about the oil sands example. So 15 years ago, every, Shell, Suncor, Syncrude, CNRL, everyone was expanding oil sands. So it went from 1 million barrels a day to 6 million barrels a day, which is about, I would say maybe 10%, less than 10% of what we're talking about here. Project overruns of 50% were common. Fatalities, safety was a disaster. And project overruns. Now, I know we talked earlier about, the good news is all these projects ran according to what they were supposed to, so they did run well when we got to them. But, I personally supervised a $7 billion project, and, I'd like to say it ended at $7 billion, but I can't. I'll leave it at that. But it's amazing how quickly you turn into absolute raving lunatics. So you've got this schedule-driven project, and you're short on welders. So yesterday you paid a welder $30 an hour. Today you're paying them $100 an hour. And you just slap it down because you've got to get going. And, I don't have any engineers. Well, I'll take that one from you. And it's unbelievable how difficult that challenge is. And we're not prepared for it, I think, at all. The good news is, young engineers, over 50% of them actually want to work in this field. They think that, and it's been phrased not as, I'm going to be an electrical engineer, it's, I'm going to solve the problem. I'm going to make the planet more sustainable. So that's good news. Engineers are going to be involved in every stage of this thing. So design, everything, as Robert talked about. Not having enough engineers is only one of about what I perceive to be 30 or 40 problems on this. But since this is Canadian Academy of Engineering, that's what we're going to stick with. But just even if you solve the engineering issue, you're going to have some problems. The other problem is around risk tolerance. So for society today, we don't have a tolerance around risks. So we over-design, we do things much differently. That consumes engineering time. And you shouldn't underestimate that. How much can we do that's boilerplate? So you just take, Robert's glasses and give them to Kevin, and hopefully, he can still read. We're not inclined to do that in this country at all, and so we need to be. So given all of that, and the CAE has obviously been noodling on this for some time, Soheil and Robert and the government have been meeting, and so following some consultation with government and industry, the CAE is actually going to launch a Leaders Summit in October of this year on Canadian engineering capacity, because there's just too much that we don't know. And so the kind of high-level theme, I would say, Robert, is to address energy transition and consider the most practical pathway for successfully meeting net zero by 2050, and what needs to be in place in terms of best practices and the engineering skills that will be needed. And somewhere in there, we're also going to create some action plans, but we'll see how that all goes. So, there's going to be a huge involvement in this, lots of parties, lots of stakeholders, and we hope many of you in this room will want to be part of that conversation. The work that's going to be done beforehand will be to understand the challenge in terms of expenditure, activity, the engineering skills and numbers, and so we want to have a lot of that pre-work done, so we're not discussing that, we're actually discussing solutions and kind of the reality of things when we get there in October. So very early days, there's a few people here on the planning committee, and we've had exactly 1.5 meetings, so the good news is if you have thoughts on this or you're interested in participating, please come see Robert or myself or get in touch with Soheil afterwards. But, I think CAE has recognized and government has clearly recognized that there can be a whole bunch of talk, but without the right engineers and the right approach to the solutions, whatever that might be, net zero is not going to happen. And that's an important starting point. And since we want it to happen, we're engineers. Nothing better than a problem that, is tough to solve. It's like, yes. So there we are. So over to you, Robert.
Well, thank you. And thanks for both of your comments. And I would like to open it up to comments from the floor. I mean, I know there are people here who have a stake in this. So I will start over there with David.
Sure. Thank you for those presentations. I just wanted to make a comment. Maybe I should use. I just wanted to make a comment. There is a lot that we don't know in Canada about the direction we're going, but actually a lot of it is actually known, and a lot of countries that are more progressive than Canada are ahead of us already. Why are we not using them as a baseline or a template to follow? So I don't think we need to reinvent the wheel here. There's opportunities to look at best practices and the strategies that are being taken by other countries that are actually turning the transition around and probably will be close to making the mark. We don't need to reinvent that, and I mean there are things that are unique to Canada, but there are also very good examples of other countries that have those problems too. So that's my comment. I think if we're looking at a strategy, we should be baselining against other countries that are ahead of us and already making very good progress. And I think, Kevin, you brought up on the educational side some aspects, for example, that Australia is doing, right? So, I could pick many, many different examples.
You know, you're right. The assumption that we're the best in the world at everything is a bad place to start. And, you know, but that's how we start. If you think even about our education system and our accreditation or regulatory, that's the premise going in. But, so, you know, it's a great suggestion. I will certainly get that back to the committee around maybe a real important body of work is, you know, let's look around the globe and what can we plagiarize, right? Yeah.
Let me just give a quick, so where we are on that issue. So we are working with, and a number of our fellows participated in the report that CATES, the International Panel of Academies, put together. It's on our website now. It's, there were, I think it's 7 countries, and where they are now and what their trajectory is to 2030 sorry, 2040. And it was an interesting exercise. It took a couple of years. It took a lot of work, mostly on behalf of the French Academy. And for whatever masochism drives us, Axel Meissen has volunteered to take over that committee and lead it on the next project, which is what is the energy futures of 20 countries going to look like between 2040 and 2060. So the first report is really a linear extension from where we are now, and the 2040 to 2060 is more of a visioning view of where we want to get to and back. So that was good. I mean, I absolutely agree with you, and you know, I made the comment here and everywhere else I've been that, you know, the difference between us and the U.S. Academy is that they've got twice as many fellows and 1,000 times my budget. And, you know, if we, they've done excellent reports, right? And we read them and pass them around, and the UK is the same. So, you know, the good news in a way is that all of these countries with their engineering academies are trying to solve pretty much the same set of problems. Where we do deviate, you know, Britain got a lot of credit for its net zero program and hitting its milestones. And when you go in and look at it, it was all about shutting down coal plants, you know, and we don't have coal plants to shut down. We can't play that card. And now that they've shut the coal plants down, they've come to a grinding halt too, right? They're not, their cars aren't electrifying any faster than ours are. We keep talking about how our energy grid is 80% renewable, which is wonderful. It accounts for 17% of our energy production. So so Canada's got some pretty odd statistics compared to everybody else. So the degree to which our energy grid is green is unique. The degree to which we produce hydrocarbons that we don't actually consume ourselves, it's not entirely unique, but it's a weird one to have in combination with our electricity. So when you're talking about the pathways, and then we've got this issue of winters and distances between cities and a bunch of other things that some of the other, I mean, we share many of those with Australia. Not the winters one, but. So just to say that you know, the devil's in the details, that we can learn a lot, and we're trying to learn a lot. The other thing that is a little weird, you know, getting global consensus is not a trivial issue, and the Paris Accord is, you know, we started with the millennial goals, and then the Sustainable Development Goals, and then the Paris Agreement. And it took a while for countries to sort of sort out what a thing had to look like for them to adhere to it. And so we've ended up in this weird problem where every country is just looking at its borders as if climate change stopped there. So, you know, we're absolutely dedicated to reducing Canadian greenhouse gases by 2050, but we're only 1.7% of the issue. So in many ways, if we work with India on reducing their coal production and coal greenhouse gases, we would save far more in greenhouse gases than we do by reducing all of Canada's greenhouse gases. But that's not the way the system is set up, and it's not what everybody's agreed to. but I think we spend far too little time looking at how Canada could export solutions. No, if the Russians would take the technologies that PTAC has developed for methane abatement in Alberta and actually apply them, we'd probably drop 0.2 of a degree. But you know, they're not going to do that. So anyway, that's my
Robert,
rambling.
so I want to be the contrarian against some of the things you said. And you know, one of the things that drives me crazy is we say we don't contribute much to greenhouse gas because of our population. But I think we're number 2 in the world in terms of greenhouse gas emission per capita. We're number 1 in the world in use of water per capita. And this overconsumption has to be dealt with in our country, for our country, not so much for the world. I'm not too fussed about Paris Accords. We should always strive to be better. And that brings me to my second piece. Net zero does my head in, quite frankly. Net zero is, yeah, I've got a lot of money. I can actually buy offsets for the crap that I throw up into the sky. And, you know, not everybody has that same advantage. And I just think we should be talking about reducing emissions rather than net zero. And we should be very targeted and focused in maximizing the way we can reduce emissions, because you know, greenwashing that occurs through the purchase of offsets is just, it's incredible. And if you look at these corporates, and not just Canadians across the world that claim to be, you know, focused on ESG, it's just astounding that they can continue to pollute at levels that are unimaginable, but buy those offsets. And more likely pollute somewhere where they don't have to follow the rules of the Canadian government. And I think we absolutely have to deal with that.
So I will, and then I'll get to a question. I will correct your statistic. I think on a year,
Just lean back.
on a year by year, I think we're about number 5 in the world on a per capita. But
5, 2, 1. We should be number 100 in the world in a per
We're in
capita.
the top 10.
But greenhouse gases are a cumulative problem. Right? So the more interesting statistic is cumulative greenhouse gases per capita summed over the last 150 years. And on that statistic, we are absolutely number 1. Like well above. And China, by the way, isn't even in the top 20 on that stat.
The other thing I just wanted to mention, because I heard this yesterday, so we were talking about making hydrogen and shipping it across the world. Like 10% of global greenhouse emissions are shipping. Why would we do that? Why wouldn't we export technology that makes hydrogen and make it in place? That's what the Australians are doing, by the way, and rather than say we're going to actually ship all this stuff across the world. And I think, again, this gets back to this knowledge-based economy, right? Let's build knowledge, and let's use that as an export on a global scale.
To chime in there, that part of the reason for that is a lot of countries don't have the area for renewables or the ability to produce that. Again, I'll come back to Germany, one of the world leading countries in this area. So they have to import, just like they're importing natural gas now.
Yeah, but they could import it from France. Somewhere close, right?
So if you're able to do that, you're absolutely right. That's exactly the way to go. But most countries don't have the area, the ability to have renewables in order to do that. So
I think the biggest thing is that the solution has to be local. It can't be one solution for everywhere. I also wanted to say that actually Alberta, 36% of the electricity is made with coal. So it's not that we don't have coal. And it went down from over 70%. But Rachel Notley closed some of the coal plants, but that's sort of stopped now. And we do have new coal mining that we have been fighting for, like because they pollute the water as well. So that's sort of just letting you know. But I just got back from UN Climate Conference in Bonn. And there were side events where scientists, engineers, activists will go, and I'll go there and listen to the data, and I'll get energy, like, you know, where am I going to get the time and energy to help with this? And then I'll go to the negotiations where Saudi Arabia, US, and so on were fighting over, we can't have this as a shall, we can't have this, and this is like going from one to the other was just this cultural shock. And I was wondering, as CAE, we had a senator here last year, so who is impacting policy. and impacting how negotiations are done. And is there a way for maybe the leadership summit or things like that to teach the fellows, especially the new fellows like myself, these other skills that we need? How do we get our agenda, not just our technology, because the technology is sort of known, but how do we get to sort of all of these things you are like negotiating over doesn't really matter, because this is basically the projection and this is the time. And so now you need to listen to us, all the policymakers, or we become one of them. Sorry.
No, it's a great point. I think the point about science and policy is very real. You know, there's a couple of science, you know, there's Canadian Centre for Science Policy or something, anyway, that, you know, are starting to influence that, but they're really, it's not prevalent in Canada the way it is in some other countries, and so it's actually great. I've captured it because, you know, it's, I think, an important element in some of the decisions that have to be made.
Yes, following up on the comment about learning from others, we also need to learn what not to do. For example, Germany shutting down their nuclear is absolutely the wrong thing to do, because they have to use lignite coal, which is the dirtiest thing imaginable, because they shut down nuclear. And the other thing is the countries such as Denmark, which have very high penetration of renewables, is a good model, but they have backup hydropower from Norway, and so every situation is different. Every situation needs to be looked at on its own merits. So, and getting back to education, I think UVic has a good model in ICD.D, where we've got multidisciplinary skills on Integrated Energy Systems Institute. And if we could move that down to a baccalaureate program where we have multidisciplinary, typically that would be in an engineering science milieu, but if it's deemed to be energy engineering or sustainable energy engineering, it would attract more women engineering students, I think, as well.
Yeah. Gary, quick comment, and then I realize I've been getting into this discussion and let the minute hand get away from me. So we want to make sure that we give full time to the next panel. So.
Yes, I have just two quick comment. I think we need to decouple the conversation on the pathways, regional pathways or provincial pathways or Canadian pathways to net zero context. I think that is one aspect. And the second aspect is what we're talking about. What I understood the conversation of this session is in the context of capacity building, engineering capacity building, in order to meet those objectives of those pathway strategies on the net zero. I think we need to two separate things where CAE has a role to play on those both of the things. Yep. But when we are mixing those two things, we are having a very mixed conversation here.
And I think, Gary, to be fair, you're catching us in a shift of strategy, right? So yes. The FEC had really, we were looking at hydrogen, we were looking at CCUS and a couple of other things, and we went to NRCan and said, you know, where are you in your cycle? How can we input, et cetera? And they said, really, this is not what we need. What we need to know is about the human resources and the engineering and the capacity, regardless of what the pathway is, right? So what you've seen played out here in this conference is, irrespective of which pathway you take, you'd better start delivering stuff on time and on budget.
Yes.
You know, you need people to turn up to put the bums in seats, right? So
I think if we're talking about bums in seats, though, we should all realize that there are tons of students applying to get into engineering in this country. We turn down 70% of the students that apply. So there's lots of spaces, but there's lots of students, but there's not the funding for the programs, and the funding comes very program specific. So, which is why I said in my remarks, we've got to lobby the government to say this is an important part of the future of this country. You need to be sponsoring seats in this particular
And that's a provincial
field.
issue, not a
It's a
federal.
provincial, but it could also be, we need to lobby together. The industry needs to really push this, and so that's an important part. The second piece is, there's so many engineers sitting in this country that can't practice engineering, and it's because we sometimes throw up roadblocks which are a bit ridiculous. And so, we're going to open what we call a clearance center in Singapore as a university, and just copying what the Australians do, to pre-clear people who come in for engineering and medicine. And if they don't have the requisite skills, to make sure we give them those in Singapore before they come through to Canada. So hopefully they work right away. But I don't know, you've all been in the same situation, I'm sure, with an Uber driver who's been an architect, an engineer, a doctor or something. A third part is, as engineers, we always insist we've got to do everything, and Heather referred to this. There's others in the system that might be able to do some of what we call engineers' works. And if you look at how medicine's changed, right, with nurse practitioners are doing what most doctors have been doing for years, for the most part, and doing it probably with more empathy and more compassion and more skill. And so, perhaps we need to look at ourselves as well and go, okay, what is in the purview of an engineer, and what could be done by a technologist or somebody else in the office?
You need to come to the summit in October, Kevin. We'll book your
So
calendar.
one more comment, and then we'll,
I think it's very important to recognize the training, the science versus the engineering. I came from the United States, we just went through the DOE
yep.
jobs, and the issue here is the funding agency, because you're talking about high-level training student is a graduate student, and the graduate student are funded. So your funding agency need to recognize those classical, traditional topics. And in thermochemical, transport phenomena, like phase flow, fluidization, react engineering, classical. It's not esoteric. And esoteric stuff, you're talking about Star Wars type of thing, or iron ore, into iron. I think that the United States is talking about using plasma, using laser beam, the things, and the biological. And I think that the classical method can be immediately used with the CO2 capture. But I think if you are emphasizing there's so much of the science from academic standpoint that you ignore the classical stuff. I think you are not having enough people trained in engineering to really help the industry. I think there's a huge shortage already in the multi-phase flow field in chemical engineering. I think this is, I hope the Canada, the funding agency recognize classical topic, even though that is some sort of a 50 years ago things, but they should be continue funded and train the people and to support the industry. So
Very interesting issue. Okay, thank you. I'm going to leave that. That was just too big a topic to open up. So let's take 10 minutes. Get back here at 5 after, and we will go into our last panel. Thank you so much.